Hello again, grade 9s. Okay, so I'm going to go ahead and do this second question for you. Again, the idea here is that you've already solved it yourself and you're just watching this to make sure that you did it correctly. In the start of the first video, I told you that I was going to do both together, and obviously I lied because here's the second one. So if you want to see the answer, scroll right to the end and the answer will be there for you. Okay, so let's go ahead and read the question. What is the maximum volume? Okay, so right away we know in the end we're going to solve for volume, and it says in liters. We'll deal with that a little bit later. Of a paint can, so it's a cylinder obviously, that uses 1,345.9 square centimeters of steel. So you should be able to identify that this, given square centimeters, right, centimeters squared, gives us a surface area. So we know the surface area. So the surface area equals 1,345.9 centimeters squared. We also know the formula for the surface area of a cylinder is 2 pi r squared for the top and bottom plus 2 pi rh for the lateral face. One other thing we know is that if we are trying to maximize volume, we are looking for optimal measurements, and we know that these cylinders are optimized when r does not equal h, but rather 2r equals h, or h is equal to 2 times the radius. And this right here is the one we're going to actually use because we can then take 2r and replace h with it. So again, I did this in yesterday's note, but basically it looks like this. 2 pi r squared plus 2 pi r, and now I'm going to replace the h with 2r. And what happens here is the 2's multiply together to give us a 4 out front. The r's multiply together, and we have 4 pi r squared for this term. This term is 2 pi r squared. So in the end, we have 2 pi r squared and another 4 pi r squared. So the surface area for an optimized cylinder is 6 pi r squared. All right. From here, what we're going to do is we are going to take the surface area, which we already know, and we're going to plug it in. So we get 1,345.9 is equal to 6 pi r squared. In the end, we're looking for the volume, but first we have to find the radius. So I divide by 6, I divide by pi. On the other side, I do the exact same thing. And once I do that, the 6's cancel out, the pi's cancel out, and r squared is equal to 1,345.9 over 6 pi. I square root both sides, and if I want, I can write a little 2 in there. Okay, and I just want to bring that to your attention because as I mentioned in class, this root sign in the 2 cancels with this other 2 here. Okay, so the cube root is the third root, the square root is the second root. You don't need to write that 2, and generally you don't ever see that 2, but it is there even though you don't see it. So once we take the square root of the left side, obviously we get r because r times r gives us r squared. And now I'm going to take the square root of the right hand side, and let me pause it, and I'm back, and I got the radius is 8.45, and of course the units for radius, the units are centimeters, and the reason that works out is because I was working in centimeters squared with the surface area. I took the square root, and all of a sudden my centimeters squared became centimeters. So there is the radius, but we need to find, as you probably remember, the volume. So this is what we've done so far, and like I did in the last video, I'm going to sort of section off an area here because otherwise the page gets too long and narrow and it looks weird. And now we're going to find the volume of this cylinder. I'm not going to review this again, but I'm just going to put right here 2 pi r cubed because that is the volume of an optimized cylinder. Again, go back in your notes, go back in the last video, find it somewhere if you don't understand why that is. Right now I'm just plugging in the radius. So obviously where there was once an r, now there's 8.45, and that's because we know that that is the radius. So volume equals, and once again I'm going to pause it and I'll come back with the final answer. And I'm back. So the final answer is 3,790. And if I'm going to round that to one decimal place, I actually get 3,791. 3,791 cubic centimeters, but the question asks for it in liters. From the last slide, you may remember that this is the same as 3,791 milliliters. And if you've ever bought a bottle of pop or any sort of juice or whatever, you probably know that there are 1,000 milliliters in a liter. So what we have here is that the volume equals 3.79 liters. And I'm just going to round that to two decimal places. And an interesting thing about this, it's a bit of a cooked example. If you look up on your phone or on the iPad, convert 3.79 liters to gallons, I believe you'll find that this is a 1 gallon can of paint. And I felt very clever. And a gallon is it's an imperial unit of measurement that we certainly still use in our day-to-day lives. I'm sure you've all heard of a gallon of something at some point, and if you ever buy gas in the US, it's in gallons as well. Okay, so I've made it full screen so you can pause it to take a look at the whole thing if you like, and that's it. I've worked through those two examples. You will have the rest of the period to get ready for the test. I've got a formula sheet for you guys to fill in. And I did say test. It's open book assignment, open book test. You can call it whatever you want. It's on Monday, and email me if you have any questions about the unit, and I can send you along a little video of me solving a problem just like I did here. So have a great weekend, guys, and I'll see you on Monday.